Hey guys, so for today we are going to be looking at a little bit more on median, kind of just wrapping it up a little bit today. I wanted to spend just another day on this because I think the other part of the lesson 12 lesson that we started on yesterday's video needs just to have just a little bit more context because I like the way that they take a few of the problems in here and they kind of test to see if you really understand what's going on with median or if you're still getting tripped up a little bit and making some errors here and there as far as like mixing up mean, median, mode, and range, or just kind of getting some fundamental details off a little bit when you're looking for median. So we're just going to look at a few more examples here, and then I'll give us the assignment as well. But what we're going to be looking at, guys, is, again, it'll have lesson 12 on the sheet, and it should have S.79 at the bottom of the page. And just a couple of details here, and please make sure to keep note of this. But on the sheet here, we're skipping that first question that looks like part B at the top of the sheet. And we're going to go straight down to exercises 4 and 5. And exercise 4 and 5 will be what we're looking at today. Take a look at those two problems, and then I'm going to kind of help set you up a little bit on the assignment. So that's what we got today. So let's go ahead and jump straight into it and take a look at the problem on exercise 4. So exercise 4 says a skewed distribution. We're going to talk a little bit more about skewed a little later, but we'll just kind of give a brief description what they're meaning by that, because they don't really get a lot into what skewed means on this lesson just yet. But just to kind of give us an idea of it, when we're talking about something being skewed, simple way to describe it is it seems like some of the data is either pushed mostly in one direction to the left or to the right. There's either going to be a ton of them on one side or a ton of them on well, not really a ton, but at least it looks like there's a lot more on one side than there is the other side. We'll get into the different types of skewed data later. They're not too hard to figure out, but they're just kind of getting into some little ideas of it here. We're not really honestly too worried about it at this stage, but they're just kind of give you a heads up for when we really start focusing more on skewed. That's what we're talking about. A lot of data being on one side or the other side of a set of data. So if we look at exercise 4, it says the owner of the chain decided to check the number of French fries at another restaurant in the chain. So if you remember, yesterday's lesson was talking about expected number of fries to get if you were at a restaurant. And we talked about, it wasn't just because the median was 82 doesn't exactly guarantee that you're going to get 82. But like I said, what the owner's doing here, he's like, okay, my median was 82. I'm going to see what this restaurant that's a competitor of mine, we're going to see what they're getting on their medians and see how we compare to each other. And then maybe that restaurant owner can kind of look at the data and see if he should change something about his or not, or maybe see if he is giving, maybe if they're offering the same price, maybe he tends to be giving more to his. And if he's not, maybe he could look into how he could give his customers a better deal, possibly. So to finish off what it's asking on 4, it says, here are the data for restaurant B. So here's the competitor's data. And they give you a long list of numbers on there. There's the list. Long list down here of numbers. There's the data of how many French fries are typically in a bag when you're ordering fries from the restaurant. So it says, pretty simple question on A, how many bags of fries were counted? Well, we know how to do this. All you got to do on this problem is simply look at that list of numbers. Look at all those numbers, 82, 83, 83, 79, 85, etc., and just count how many individual numbers are in that list. And if I do count it through this list, I should get an answer of 19. And again, we can double check here. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 19 data points in that list. So that's all you got to put on A, 19. On B, now we're going to kind of get into some ideas here about some common errors on median. And I kind of say this, guys, because median is one of the ones that's the easiest to mess up just because there's more details to it to consider in that it's the only data one of the 4, mean, median, mode, and range, that recommends or really requires you to list them in order. And a lot of times you might just want to take the easy way out, or you may just be rushing through a problem and not remember to order them, and which can easily make it where you miss it, or just some other little things about it that we'll get into on this problem too that might cause us to slip up. So we're going to look at a few here, and there's going to be a few of the kids here are going to attempt to figure out the median, and we're going to figure out, are they right or are they off? So on B, it says Sally claims the median is 75 because she sees that 75 is the middle number in the data set listed above. Kind of makes sense. She thinks half of the bags had fewer than 75 fries because there are 9 data values that come before 75 in the list, and there are 9 data values that come after 75 in the list. Do you think she would change her mind if the data were plotted in a dot plot? Why or why not? Okay, well, again, it makes sense what she's saying here. She's saying, okay, I have a list, and I remember, if I think about it, median is the middle, so I'm just going to look at that list and find the middle number in that list. And when she did that, she saw that there was a 75 in the middle. She looked through there and saw, okay, it appears that 75 is pretty much in the middle here, because I see 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers over there. And then I see 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers over there. So that would be an understandable conclusion to come to, that, okay, 75 has to be in the middle. So a couple ideas here. First off, we can just kind of get an answer in the question. The question says, do you think a dot plot would have changed her answer on this question? Well, think about what a dot plot does. What a dot plot does is it puts the range of numbers at the bottom of the dot plot in order from least to greatest. And then you just put the individual dots above each number to figure out where each of them go. Now think about how that might help. Well, first off, think about what I said, least to greatest. What a dot plot does is it's going to guarantee that you have the dots put in some kind of order, and the stacks will go from least to greatest. So a couple ideas. First off, it gives you an idea of order here. And second off, it's a lot easier to see median on the dot plot than it would be just a randomly ordered set of numbers that have no pattern to them, which is what's happening on this list. The numbers are jumping around from the 80s down to the 70s, back up to the 80s, and just keep fluctuating. There's no real order to them. But the dot plot gives it an order. Then when you look at a dot plot, you can kind of look and see numbers that, at least if you're estimating it, you get a pretty decent estimate of where the middle of that dot plot would be. So I would think that a dot plot would be a helpful tool here when trying to figure out, okay, is 75 a reasonable choice or answer option for the median, or does it look off? And if you were to make a dot plot on here, which we don't have to do it on here, but just to save us a little bit of time, if you did, you would notice that the expected answer would not be 75. And honestly, guys, just kind of thinking about it, 75 it really won't honestly be that close to the median. So a couple ideas to think about that too. So we're going to think about that in terms of, okay, first off, yes, dot plot helps because it puts it in order. And that's really honestly the big idea here. Because if you think about what she did, really it's not what she did, it's what she forgot to do. Because it sounds great to just pick the middle number in that list, but think about what's wrong with that list. So what did she forget to do in that list? Well, she clearly forgot to put it in order from least to greatest. So it might seem like 75 is the middle, but if you don't put it in order, that's going to give you a false middle. It needs to be in order to really determine what's in the middle of that list, because the list needs to be ordered in order for a middle to really appear in that list as far as how big or small it is. So what I said on this answer, as far as do you think she would change her mind with a dot plot, I said yes, because the numbers are not listed from least to greatest, but a dot plot does put them in that order, which would show a different median compared to what she got. And I'm going to add that to mine. Different median than hers. Or I guess than Sally's, to be more specific. So here's my answer on B. It's a little long here, but here it is. So that's what I put on there. Feel free to pause it here if you need to write that down. There it is on that first, on part B for Sally. Okay. So dot plot would have helped you out here simply because it puts it in a better order to visualize, is the simplest way to put it. Okay. So we have another person. So Sally gave it a shot and it didn't quite work out. So we're going to have to look at another idea. So Sally had a decent idea, but not ordering it threw her off. So here's Jake's idea. Jake said the median was 83. Doesn't give an explanation, just says he thinks it's 83. So we're going to have to kind of dive into the data here and see why it's 83. So it says, what would you say to Jake? Well, if I look through this data, just to kind of, again, we're going to find a median here in a second, but just to kind of save us a little bit of time here, and honestly, guys, if you wanted to, you could go ahead and find the median and see if he's right. But if you did that and you follow the steps correctly, you would find that the median is not 83. But we're going to figure out instead, okay, if it's not 83, what caused him to think it was 83, right? So if I take a look at my list, I'm going to go ahead and save myself a little bit of time here, but I'm going to circle all the 83s in the list. And what I'm going to see here is there's a pretty decent amount of 83s in this list. So if I go through all my circles on that list, I actually find 83 to show up in that list 5 times. Okay. There are 5 83s in that list. And honestly, guys, if you kept looking through this list, and it's a little harder to do that simply because there's not an order here. Again, that's another strength of putting numbers in order on a list. You only technically have to do it on median, but it really helps with other parts of the data analysis too, particularly mode and range, because it helps you visualize, first off, for range, it helps you visualize, okay, now since they're in order from least to greatest, it's pretty obvious which one's the biggest and which one's the smallest because it's right there in order. And as well for mode, if you have them in order, you're going to see numbers that show up multiple times a lot easier, because when they're in order, if you have more than 183, they're going to be all side by side right there. So it's a lot easier to count them than it would be if they're just spread out in a random order with no pattern whatsoever to them. Well, what I'm going to find about 83, guys, is if I checked every other number on that list that as a possible option, 83 is the most common number to show up in that list. In other words, it shows up the most. Well, what do we call the number in a list that shows up the most? Well, we call it the mode. Therefore, Jake is incorrect when thinking that the median is 83 because he did not find the median. He simply found the mode. So all I put on C is I said that 83 describes the mode, which in parentheses I put most common, but not the median. So that was C. So again, I said the 83 right here, 83. Sorry about the lighting here. 83 describes the mode, which is the most common one, but not the median. Okay, there it is. A little better to see there. So there is part C. Now, that being said, that doesn't mean that median and mode couldn't be the same here, guys. It could have been that whatever answer the median was, it was also the number that showed up the most. But in this particular problem, it was simply 83 was simply the mode. So Jake, again, decent idea, but he got median and mode mixed up. So that one is not what we're looking for either. Okay. So on D, we have another one giving it a shot. Betsy's going to give it a shot. Betsy argued that the median was halfway between 60 and 85, or 72.5. Do you think she is right? Why or why not? Well, let's think about what Betsy did. If I were to look at my list, guys, and again, we've seen it a few times at this point, so I don't think we need to keep popping it up there. But because you guys, you have the list right in front of you, so no need to keep putting it up there. So 60 and 85. If I'm trying to look at my list down there again and think about where 60 and 85 came from, what she found with 60 and 85 was that 60 was the smallest number in the list, so she took that number, and 85 was the biggest number in the list, so she grabbed that, the biggest and the smallest number. And it sounds like if she wants the halfway point between them, it sounds like she took those numbers and found the average of the two numbers. Because if you average out 60 and 85, add them up and divide by 2, you do get 72.5 for an answer there. So it appears that what she did incorrectly here was, and again, before we get into that, think about that. Is that how you find the median? Is median simply take the biggest number and the smallest number and average them up? No, it's not. So now there are times when you can do that to find the median. You can find the median if you have, remember, two numbers in the middle. Then once you know that there's two numbers in the middle, you can add them up and then divide it by 2. But that is when you have already ordered them from least to greatest and you have worked your way to the middle until you found the two numbers in the middle. If there's two numbers in the middle, there could only be one, but keep in mind that is an option to find median, that you have 2 in the middle, then find the average. But finding the minimum number and the maximum number and averaging them out is not how you find the median. So for part D on Betsy's idea, I said no, she's not right, because you don't use the average of the biggest and smallest number to get the median. It's just not a possibility here. So again, that's what I got on part D. So there it is right there. All right. And you can pause that if you need to write the rest of it down, but that's what I have on D. So that was the first sheet of the notes. And so far, looks like Sally, Jake, and Betsy all gave it a good shot, but they all had some little detail about median that they were not understanding that caused them to miss it. So on the second page of the notes, so if we move over to the second page on our notes, there is another option here that we could try. So we have a fourth person that's going to give it a shot here, and his name's Chris. And Chris says that he thought the median was 82. Do you agree? Why or why not? So at this point, I went ahead and found the median. Now, to be totally honest, it probably would have been a little more useful to just go ahead and find it at the very beginning of the problem, because then it would have been it would have been more obvious to understand, okay, was it right or not? Because you'd already know what it should be. Then you could go back and look a little more. But we were able to figure it out without it, so it's not too big of a deal. But at this point, you could look at the idea of 82 and look through that list and not really find anything that stood out about 82 as far as like being the biggest or the smallest number or the most common number. It wouldn't fit under any of those. So if you exhausted all those options, you probably would have at that point, when you got to E, said, okay, well, let's just figure out what the median is and see if Chris's idea of 82 is correct. So what I went ahead and did, guys, is I put the numbers in order from least to greatest. And I'm going to write them back up here again just to kind of help us out here. So if I took that list on the first page of notes, guys, and I put them in order from least to greatest, I would get 60, 70, 74, 75, 76, 76, 78, 78, 79, 82 four times, so 82, 82, 82, 82. Then I have 583, so 83, 83, 83, 83, and one more 83. And then it looks like I finish it off with an 85. So if we want to double check and make sure that our numbers are right, we can count them and see if it had the same amount of data points as we had on the first question. And if you remember on the first question, it asked how many bags of fries were there or how many data points, and there were 19. So let's see if we have 19. 1 on 60, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it appears that we didn't forget any of them. We have them all in an order, and that's the first step to median again, least to greatest. Now, guys, if I were to simply go through this and work my way to the median, let's see what we end up getting. So remember how to do median, guys. You just start crossing off numbers on both sides till you make your way to the middle. So I have several here, but I'll just go one at a time just to kind of keep it in the same idea we've been doing. So 60's out and 85 are out. Got rid of the biggest and the smallest. 70 and 83. 74 and another 83. 75 and 83 again. 76 and another 83. The other 76 and the last 83 got crossed out. The first 78 and 82 are out of there. Another 78 and another 82 are gone. And then lastly, I marked out the 79 and another 82. But in this situation, I can't cross off any more of the numbers because there's only one number in the middle. And looks like we finally have a winner here, I guess you'd say. We have someone who has figured out the median correctly. Chris was on point, and it was 82. Because if I do put them in order and find the middle, there's only one in the middle, and it is one of those 82s. So Chris would be correct. And what I put for Chris's number, or for his answer, is I said, do I agree? Yes. Because if you order the numbers from least to greatest, 82 is in the middle. And I just rewrote what I already had up at the top. I wrote that explanation, and then I put the numbers in order again down there and found their median. So that's what we have on E. We finally have a correct answer. We had several, gave it a really good shot, but Chris was the one that was able to figure out that 82 was the correct median. So on E, Chris got it. All right, so we're going to look at 5 real quick, and then we're actually going to take a look at problem 6 as well. And I had to modify it just a little bit on 6, but I'll clarify what it's going to look like on your notes here, just to kind of help you out a little bit on that. So when I'm looking at parts or on number 5, exercise 5, it says calculate the mean and compare it to the median. What do you observe about the two values? If the mean and median are both measures of center, why do you think one of them is smaller than the other? Okay, so what I went ahead and did here, guys, is I already know the median, 82, but we also needed the mean. What I did for that is I just saved us some time and went through the steps to find the mean. I added the numbers up and divided by 19 because there's 19 numbers in the list, right? And when I did that, I ended up getting a mean of 78.6. So here's the mean and here's the median. Mean is 78.6, median is 82. Sorry. And if you want to go and calculate it, that's fine, guys, but should get 78.6 as the mean. So let's talk about it because they asked a good question, because mean and median are both ways of getting an idea of where the center amount on a data set should roughly be, where you consider something around an expected value. And they make a good point because 78.6 and 82 are a decent amount apart when you think about it. They're a little over 5 apart, which in this case would be fairly significant when you're talking about trying to get out French fries. I mean, five or six fries, it might not seem like a big deal, but it could be a big deal to someone buying them. So we're just going to consider the idea that 82 and 78, I'm sorry, not 5, guys, my apologies, about 3.4 apart, which might not be a big deal, but to some, maybe it is. Maybe you got some that are just really particular about it. But the idea we're going to have on here, guys, is 82 and 78.6 are at least a noticeable amount apart. And we're just going to say, what do you think might have made one particularly smaller than the other? Which in this case, the mean was smaller. So when we're looking at these, guys, when we're taking a look at it, what might we think made the mean smaller? And to do that, what might be helpful might be to take a look back at the list. So I'm just going to throw it back up here and ask ourselves, do we see a number up on that original list? Which I'll just go ahead and show the second list down here since I didn't cross stuff off. But if I look at this list down here, that blue list right here at the bottom, do we see any number in particular on that list that it kind of stands out as far as being either noticeably bigger or smaller than the rest of the numbers? So if I take a look at it, if I'm going on the top end, these numbers are staying pretty close. I mean, 78, 79, 82, 83, 85. Nothing is just jumping out as far as getting a lot bigger or smaller than everything else. Like, in other words, there's not a standout. So if I have to take a look though at the other end, okay, we have 78, 76, 75, 74, 70 made a little jump, but look at 60. 60 is 10 less than any other number on the list. Well, we're thinking about how close these numbers were together. An amount of 10, that big of a jump, is pretty significant. So to me, 60 in a way is a bit of an outlier here. In other words, it seems like it's noticeably bigger or smaller than the rest of them. In this case, smaller than the rest of them. So think about what 60 is doing here. So 60, think about what it might do to the average, particularly if we think that 60 kind of doesn't belong on this, like shouldn't be on this list. It doesn't really belong with our other numbers because it just kind of makes a big jump, that big gap of 10 as far as how close is this to the other ones. So we could kind of think of 60 in terms of maybe we shouldn't count that number on this because it seems like somebody messed up clearly when they were getting the fries together. I mean, and it makes sense. It'll happen. I mean, maybe someone's in a rush. They're dumping fries in, and this time they're really sloppy about it, and several fries in the scoop fall out and miss the container. Maybe that's something that happened. And if we're going to consider that, would we think that that's a very fair representation of how many fries you would expect to get? Well, I would say no, because if that's not going to be something you're going to expect to happen a lot, if they're pretty consistent at filling in the containers. Um, I wouldn't expect that big of a drop because they're not going to want. I mean, think about it. If you not only are getting less than the mean or the median, think about that. Just the smallest number you were 10 away from. Well, in this case, the median was 82. The center of that data was 82. So that's kind of an expected amount, somewhere around 82, at least in the 80 range, close to 80 if you're using the mean as a predictor. But even then, 60, that's a considerable drop. If you're expecting somewhere in the 80 range, low 80s for the amount of fries to get, and you get 60, you're probably not going to be very happy about that. And you're probably not going to be as likely to come back to that restaurant. So to me, I don't think 60 is a fair representation of the restaurant because it just sticks out too much. And I would think that in itself is probably the reason the mean is so low. Because think about what might happen. And actually, I think let's just go ahead and look at what the mean might be if that 60 wasn't there. So I'm going to go ahead and find the average of those numbers again if I ignored the 60 and see if that would make enough of a difference or at least get it closer to the median. So I'm going to pull out my calculator here. And I'm just going to go through this list and skip the 60. So I have 70 plus 74 plus let's see, a 75 plus two 76s, so 76 plus 76 plus I have two more 78, 78 plus 78 plus a 79 plus 82 plus 82 plus 82 plus 82. That's four of them. Then I have 583, so plus 83 plus 83 plus 83 plus 83 plus 83. And then finally I have an 85. Okay. Which gave me 1,434. I'm just going to write that in here. And if I took that 60 out, instead of having 19 values, I'll now have 18. So to find the median, to find the mean, I'm going to divide by 18. And it changed it at least a little bit on here. When I divided by 18, I did at least get a little bit closer to the median. I got 79.6, roughly 79.6. Really, if I round that, because it's 79.6 repeating. So if I found the new mean, which is right here, I did end up getting a mean of 79.7, which is at least a little bit closer to that median of 82. So it at least made somewhat of a difference to have that 60 in there, which makes sense. If you get rid of the lowest number on a list, it makes sense the median is going to at least go up a little bit. So it at least made somewhat of a difference to have that 60 in there. So what I went ahead and said, as far as answering the question of what I think made it smaller, I went ahead over there and said 60 caused the mean to get lower. Now, that being said, even if you consider the lowest value, it still doesn't get it as high as the median. But again, at least it gets the numbers a little bit closer to each other. So that's what I got for that. So to finish it off, guys, let's look at exercise 6. And here's what I'm going to have on here, guys. I am going to, on your notes, I'm going to go ahead and, so on this page, it cuts off. It doesn't give you part B normally on the page, but I'm going to edit the page and put in part B and go ahead and give you the list on it. And that way you'll have it on your notes to follow along here. But just keep that in mind. I'm going to have to type it in for us because it actually got put on the homework sheet. But I'm going to move it around for you guys so you can follow along a little easier. So anyway, this one will be pretty easy one to finish off, exercise 6. So on number 6, it says a third restaurant. So I guess maybe, and this is honestly not a bad idea. You don't just want to look at one competitor when you're trying to figure out how you're doing, because you might have found a competitor that just kind of stood out. Maybe like if you compare it to other restaurants, maybe you're a lot closer to what the other restaurants are doing. And maybe this was just the one, maybe there was just one restaurant in particular that stood out as far as how high or low it was on fries. So it probably isn't a bad idea to at least look at more than one restaurant to give yourself a more general idea. Really looking at three or more is probably more reliable because the more you look at, the more of a pattern you can find. That's just what I would think about that. But this restaurant owner, he or she, is smart in that they are not just relying on one competitor to compare to theirs. They're looking at more than one. So, a third restaurant, C, tallied the number of fries for a sample of bags of French fries and found the results below. So we're going to assume restaurant A's owner took a look at this data distribution. So what they did here is there's the frequency table. So again, I'm going to kind of focus on it. I'm going to fold it down so we can kind of take a look here. So here is the frequency table they give us on 6. And what I did here, guys, is I went ahead. Really, guys, these are the tallies, not really the frequency. I typically put frequency in numbers. So I just took the tally marks for each amount of fries and put their frequency numbers over here on the right. 2, 1, 2, 3, 5, 4, 1, 1, 0, 3, 3, and 1. And that helps me out a little bit when it comes to figuring out the answer to part A and really figuring it out in general. So let's just take a look at it and give it a look. So on A, it says how many bags of fries did they count? Well, 2 ways you could do it. You could either go back up to that frequency table and count every tally mark up and see how many you got, or you could do what I did and put a number next to each tally amount and then add those up. I mean, I can show both. It doesn't really matter. So if I'm pulling this up here, guys, I see 2 tally marks. I got 2. 1 more makes 3. 2 more makes 5. 3 more makes 8. 5 more makes 13. 4 more makes 17. 1 more makes 18. 1 more makes 19. 3 more makes 22. 3 more makes 25. 1 more makes 26. So there's that way you could do it, 26. Doing it that way, or I could just count my numbers. 2 plus 1 is 3, plus 2 is 5, plus 3 is 8, plus 5 is 13, plus 4 is 17, plus 1 is 18, plus 1 is 19, plus 0 is still 19, plus 3 is 22, plus 3 is 25, plus 1 is 26. So either way, I do get an answer on there of 26 on A. How many bags of fries did they count? 26. All right. So here's where I had to edit the page a little bit because there's only one other part on this question, and I don't know, totally get why they let it cut off like that, but they had a lot of information to put on these sheets, so I'm sure they had to cut corners here and there. But there was a part B to this question, so I'm going to make sure that you can see it on your notes too when we go over it. So I'm going to just fold it down here and go ahead and talk about it because I just wrote it by hand here at the bottom. I'll type it in on your notes so you'll have it too. But here's what it says. It says, basically, it words it a little bit different, but I just kind of got to the point on this question. It's just saying, what is the median number of fries on B? And I'll type that on yours. And like I said, and here's what I did. I took the list, and this list came from up here. I went through and said, okay, I'm going to need 2 75s, 176, 2 77s, 3 78s, 5 79s, 4 80s, etc. And I made a list based on those frequencies. So if I look back, there's the list I got. There are the 2 75s, the 176, the 2 77s, the 78s, just etc. That's all I did to figure out this list. And I want to find the median. So here's what I did. I went ahead and I'm going to probably leave it honestly on both parts of the notes because this will help you on the homework a little bit too. So notice how I put a line right in the middle of this data. That line represents the middle because if I count the numbers on either side of the line, I'm going to notice that there are 13 numbers over here you went ahead and counted them, you get 13 numbers over here, and there are 13 numbers on the other side of the list. So that line that I put in the middle, so this line I put in the middle here, what it did to my data is it cut it into two equal halves. It gave me 13 on one side and 13 on the other, 13 on the left, 13 on the right. And that will be helpful for you later when you get to the homework, and we'll explain that in just a second. But what I'm finding with that line is that they're actually, and if we think about yesterday's idea, what we wanted to grasp from yesterday was if you're looking for median and there's an odd amount of numbers in the list, you're going to have one number for the median. If you have a list and you want the median and there's an even amount of numbers in the list, you're going to have two numbers in the middle, and you're going to have to find the average of those two to get the median. Well, think about what we had. On A, we said there were 26 bags of fries. Well, 26 is an even number. Since it's even, we're going to expect two numbers in the list in the middle. Well, if I go back up and look at my list here, what two numbers do you think are going to land in the middle of this list based on what that line I drew? Well, if I'm looking at this based on that line, I'm going to assume that 79 and 80 are the two in the middle. And if I were to circle the two in the middle, I would find that there's 12 on one side and 12 on the other. So it does sound like, though, you need both of those two numbers to be in the middle to keep it even on both sides. So I would agree that I'm going to go ahead and circle the two in the middle. That I have 79 and 80 are my two in the middle. Okay? Well, if I have two in the middle, remember what we do. We add them up and divide by 2 to find the average. Or you could possibly just do some mental math and figure it out too. But if I add 79 plus 80 and divide it by 2, I do get 79.5 as a median. Now, keep in mind, when you're doing this in a calculator, you might want to do it one step at a time, like put 79 plus 80, get that number, which if I did that, I should get 159. And if I divide by 2, I still get 79.5. So just keep that in mind if you're going to put in a calculator. Adding these two up gives you 159. Divide by 2, you get 79.5. There is the median. That's the answer to B. Okay. So that's it on the notes. So what I'm going to do, guys, is I'm going to pull up the assignment for today. And it'll be under the homework option. But if I'm to look at that one, what you're going to see on the page, guys, is they're going to ask at the top, part B, what's the median? We just did it on the notes. If you couldn't get it to work on the notes, you can go ahead and just type the answer in that we just did right here. You can go ahead and put that on the top of your homework. But keep in mind, the problem that I'm grading on this homework is number 7. So also, I'm going to put it on the homework too. I'm going to type it in there. But number 8, skip number 8. I'm going to skip this problem on the homework. So you're only looking at number 7, A and B. Number 7 says, a unique name here. I guess I would call that Robert. Wanted to look more closely at the data for bags of fries that contain smaller numbers of fries and bags that contain larger numbers of fries. So he's going to analyze the lower numbers of fries, and the higher numbers of fries. He decided to divide the data into 2 parts. He first found the median of the whole data set and then divided the data into the bottom half, the values in the ordered list that are before the median, and the top half, the values in the ordered list that are after the median. So to kind of talk about what he means by that is basically what I did on this problem right here. If I were to look at this, guys, I have a lower half all the way to, and keep in mind, 80 is at the beginning of the lower half. So if you were to break it up into halves, make sure to count the 80 when you're looking at the upper half. And when you're looking at the lower half, pretty obvious, lower half is the lower numbers. The lower half, make sure to count that last 79 when you're putting the lower half in on the homework. Because what they're saying is take the 13 lower numbers on part A, because on part A, they are asking to list the 13 values of the bottom half in the bottom half and find the median. So I'm going to put the list on this sheet, probably above number 7, just so you can go back and reference it if you need it. But they're saying list those lower 13 and find the middle of those 13 values. Keep in mind, you have an odd number of values now, 13. So you're most likely going to get one, and well, you should get one value in the middle. If you do it right, you'll get one value in the middle. And just find what that median would be. And this is going to be, this question is a great lead-in for tomorrow's lesson when we're getting into looking into box plots and how to make them, otherwise known as box and whisker plots. But don't worry about that yet. And then on B, list the 13 values of the top half, so the bigger 13 numbers, and find the median of those. So you're going to find the median of the lower half, and you're going to find the median of the upper half of the numbers. And again, there's 13 numbers in the list, so you should only get one number in the middle. Okay? And that's all you have to do on your homework, guys. Just find the median of the upper half and the lower half. And again, it's going to be a great segue into tomorrow's lesson when we start looking into how to create box plots. So if you understand that part of the homework, you're going to have a great head start on how to look into box plots, because you'll have almost everything you need to figure them out. So that's all I got for today, guys. Please make sure to reference back to this video, go back to different parts of it if there's parts of the notes that you're confused about. If you're still confused, please make sure to email me, message me on Google Classroom, either one, and I'll be happy to help clarify some questions. I already had some questions from yesterday's assignment that we got cleared up, so thank you guys for emailing me and asking about it. And just let me know what else I can do to help you guys. So good luck on that, guys, and have a good rest of your day.